You know, you click a button and a movie starts streaming, or you send a message and it instantly appears halfway across the world. It feels like magic, right? But it's not. It's all thanks to this invisible blueprint that runs our entire digital lives. Today, we're going to pull back the curtain on that blueprint: network architecture.
So let's just start with the biggest question of all. How in the world do billions of devices, I'm talking phones, laptops, even those smart fridges, how do they all talk to each other without it being total chaos? Well, it's actually a super organized system, and it really all boils down to two fundamental designs. And this master plan has a name: network architecture. It's basically the set of rules for how computers get connected and how they share everything from files to services. We're going to break down the two big models you use every single day, probably without even thinking about it: client server and peer to peer. All right, first up is the model you probably interact with most often, the client-server architecture. Now, to make this super easy to understand, I want you to think of a restaurant. You've got the diners, and you've got the kitchen.
Okay, so in this setup, you have one powerful central computer called a server. This is the kitchen. It holds all the important stuff, all the data, the apps, the services. It's the single source of truth. Your phone or your laptop, that's the diner, or what we call the client.
The whole process is actually pretty simple. The client, that's you, sends out a request. Maybe you want to check your bank account balance. The server gets that request, does its thing, finds the information, and then sends a response right back to your device. It's just like ordering a meal from the kitchen.
And the perks of having this one central hub are huge. You get amazing control over everything. Security is way tighter because you only have one main place to defend. Backing up data is straightforward, and the whole system can grow really, really big. I mean, think of a great restaurant that can serve thousands of people a night without mixing up a single order. That's the goal here.
But there's always a but, right? What happens if that kitchen suddenly closes down? Well, nobody eats. That single point of failure is the biggest risk here. If the server goes down, the entire network is down. Plus, running a high-end kitchen like that is expensive, and you need a professional chef, or in this case, a really skilled administrator to keep it all going.
And you see this model everywhere, especially in places where security and control are absolutely critical. We're talking about your bank's app, your company's huge internal database, or even the web server that's delivering this content to you right now. They all depend on this centralized structure. Okay, now let's flip the script and look at a completely different way of thinking. If client-server is that formal restaurant, then our second model, peer-to-peer, or P2P, is like a potluck dinner. Everybody brings something to the table, and everybody shares. See, in a P2P network, there is no central server, no kitchen. Every single computer is an equal, or a peer. That means each device can be both a client and a server, sharing things directly with anyone else on the network. There's no middleman at all. So the way it works is just totally different. One computer might just shout out, "Hey, does anyone have this file?" And another computer on the network can answer, "Yep, I've got it," and then send it over directly. It's this decentralized conversation, kind of like asking around at the potluck to see who brought the mac and cheese. The good things about this are pretty obvious, right? First off, it's cheap. You don't have to buy some big fancy server. It's usually super easy to set up for a small group, and you don't need a pro to manage it. That makes it absolutely perfect for simple stuff like sharing a printer in a small office or at your home. But just like a potluck, things can get a little chaotic. Security can be a real problem. I mean, who knows what's in that dish some stranger brought? There's no central place to manage or back up data. And as more and more people join the party, things can get really slow and disorganized. Performance tends to go down as the network gets bigger. You've definitely used P2P, probably without even realizing it. When you set up a home network to share a printer with your family, that's P2P. When you send a photo to your friend using Bluetooth, yep, that's P2P too. And of course, the most famous, or maybe infamous, example is torrent file sharing system. All right, so we've got our two different approaches, the super organized restaurant and the free-for-all potluck. Now let's put them side by side and see how they really stack up against each other.
When you really boil it down, it's a difference in philosophy. On one side, you've got the client-server model, which is all about centralized control. And on the other, you've got peer-to-peer, which is all about decentralized freedom.
This chart really lays it all out. Look, for control and security, client-server wins hands down. But when you look at cost, peer-to-peer is the clear winner. Performance is usually much better with a server, but P2P is way easier to manage if you've just got a small group. It's a classic trade-off, really.
So after all that, which one is the champion? Which architecture actually wins the fight? Let's get to the final verdict. Is it the super secure, powerful server, or is it the flexible, cheap network of equals? Which one is actually better?
And the answer is neither. The best one is simply the one that's right for the job you're trying to do. It's not a one-size-fits-all situation. If you're building a banking app, you need the bulletproof security of client server. But if you're just sharing some music files with a couple of friends, the simplicity of peer-to-peer is perfect. So here's the real takeaway. The most important thing is to understand the choice you're making. It's this constant balancing act between centralized security on one side and decentralized flexibility on the other. And as technology gets crazier, you're going to see these models start to blend together to create really cool hybrid systems. But that basic trade-off, it's always going to be there.
So I'll leave you with this little challenge. The next time you open an app or stream a show or send a file, just for a second, ask yourself, right now, in this moment, am I the client talking to a big server, or am I a peer talking directly to someone else? Once you start looking for it, I promise you'll see these two blueprints absolutely everywhere.